Go ahead and fill these up with the hydrogen water. We're going to measure the ORP, and we're going to see how pH influences the reading. Okay, so add pH drops again into all three of them. Ammonia to this one, and vinegar to this one. And then we need an ORP meter. Yeah, ORP. Okay, so this is the pH of this is slightly acidic, and it's giving a negative 563 60 millivolt reading, okay, in a slightly acidic water. This is probably what, pH 6.5 or something like that. I don't know. So it's just slightly acidic. Negative 557. Okay. Now we're gonna. What do you think is gonna happen? We're gonna put this into the acidic water. Okay. And watch what happens with the negative ORP. Now notice the concentration of hydrogen is identical on all of these, right? It's really, I mean, maybe it's diluted a little bit because we added a little bit of vinegar, but you saw how much it was. It was a very small amount. The concentration, if we measured it with the reagent or gas chromatography, the H2 concentration would be the same. Okay. Now this was negative 560 millivolts. Now this one is acidic pH, more acidic, and we're going to measure it, and it's negative 399, negative 400 millivolts. Okay. Now, so it went down a whole 100 millivolts, even though the hydrogen concentration is the same. Okay, just think about that. The H2 concentration is the same, only the pH changed, yet this one has a negative 400 millivolt difference. Now, this one, right? Any guesses what's going to happen to it? It's going to be more negative, right? Let's see what it is. Negative 600, negative 700, negative 750, negative 780. Okay, climbing, negative 800. It's over negative 800 millivolts. pH 11 or so. And so this is really important, and this is why ORP cannot be used to estimate the therapeutic value or the concentration of hydrogen gas, because it's so dependent upon pH and also temperature and a number of other factors, okay? I want to show this complicated graph. You already did the demo, but you can actually see how this works, okay? So on the y-axis, you have the ORP, and on the x-axis, you have either pH or H2. Now, if we look at the solid line, that's going to be the ORP versus the H2, and you'll notice that the concentration doesn't change, or the ORP doesn't change at all. The ORP stays like exactly the same, even if you go from an H2 concentration from like essentially 0 up to 14. The ORP stays almost the same. If you keep the H2 concentration the same, so in this case, like the H2 concentration either 0.16 or 1.6, if you keep those the same, first off, they only change by like 15 millivolts by changing the concentration by 100, 10 times, right? 0.16 to 1.6. You change the H2 concentration that much, the ORP hardly changes. But as you change the pH, the ORP changes dramatically,